Welcome to Khetztutorials, and in this video I will be doing examples, and these examples are related to circle geometry. And before I start, I just want to say that you should make sure that you know like a lot of the theorems or a lot of the principles which you have to apply, because basically you can't apply something which you don't know. Also, there are quite a few ways to solve each problem. Some problems only have one approach, but others have quite a few. So as long as you understand the theorems, you're good to go. Just apply whatever comes to your mind first, right? So let's start. Let's get right into it. Please subscribe if you haven't subscribed. And if you like the video, go ahead and give it a thumbs up when you're done watching. And if anything isn't clear, please let me know by leaving a comment, right? So given this diagram over here, this is the first one that we're going to do, and we're asked to find ABC, so the angle ABC, which is over here. So you're asked to find that value, and so what do we see? So this is all about seeing. Open your eyes and see, right? So dealing with this question over here, and so we want to find ABC, and we're given 56 as this angle BCD, and we're also given 80, which occurs here at this point, right? So we can use this information to our advantage, and the first thing that I see is that this 80 is actually an exterior angle to this triangle over here, right? And we know that the exterior angle of a triangle, so the exterior angle, so this we're going to say CDA, so CDA plus 56 is equals to 80. And the reason for that would be that an exterior angle of a triangle, so the exterior angle of a triangle is equals to the sum of the interior opposite angles. So this 56 and this angle here should add up to the exterior angle, which in our case is 80. So now we can actually find this angle over here, which is CDA, and the value of CDA should be 80 subtract 56, right? And the answer you should get from that should be 24. So you now calculated that this is 24 degrees. The value of that angle is 24 degrees. And we can now translate this 24 degrees to this point. And this point is actually the point which we're interested in. So you actually have the value of ABC equals to CDA. And the reason for that would be that these two are in the same segment. So angles in same segment. Or there's another reason which is quite similar, or which is basically the same, that says arc AC subtends, so this arc, if you can check, it subtends ABC, also subtends ADC, and that is why these two are actually equal, because of that arc AC. And the reason for that would be angles in same segment, or arc AC subtends, something like that. And therefore, we finally have our value for ABC, and we can answer the question by saying ABC is equals to 24 degrees, right? And that is our answer for this first question. So we first found the value of CDA, which is over here. After finding the value of CDA, we transferred it to this side. And the reason for that was that it is, so the angles are in the same segment, and therefore ABC is equals to CDA, with a value of 24 degrees. Now moving on to the next one. So this is the next one that we have with us. And we are asked, so let's first analyze the diagram. So at first you'll see that the corners, or the vertices of all right, so all the vertices are actually found on the circumference of the circle. And we have 1, 2, 3, 4 points, which qualifies this to be a cyclic quadrilateral. So a cyclic quadrilateral is basically just a polygon with 4 sides which corresponds with 4 vertices, and these vertices have to occur on the circumference of our circle. So now that we know that this is a cyclic quadrilateral, we can actually apply rules which are associated with cyclic quadrilaterals, right? So the first thing that you will notice is that you have a diameter, because we're told that O is the center. So a line that passes from one point of the circle and goes all the way to the other side of the circle qualifies to be, and passes through the center, qualifies to be called a diameter. Now that we have a diameter, we can say, or we can conclude that this angle over here is 90 degrees. So ADB is equal to 90 degrees, and the reason for that would be angle in semicircle. So the diameter divides the circle into 2 parts, and whatever part is formed by joining lines from the diameter to the circumference and from the circumference back to the diameter forms a 90-degree angle according to this rule, right? And that is why we concluded that that is indeed 90 degrees. Now that that is 90 degrees, you can find the value of this angle over here, which is ADD, and the value of that would be, so 180 degrees subtract 90 degrees, which we just found over here, and then subtract the 30 degrees which we have, or which we were given in the question. And the reason for that would be third angle of triangle, or another reason would be angles of triangle. So all of the angles in the triangle ABD have to add up to 180 degrees, and that is why I subtracted the 2 angles from 180 degrees to get the final angle, which is ABD. And the value you should get over there should be, so this is 120, so it should be 60. So that is the value of this angle here. Now that we have this angle, we can apply a rule which only applies to cyclic quadrilaterals, which says the opposite angles of a cyclic quadrilateral are supplementary. So this angle ABD, which we have over here, added to this angle over here, which in our case is X, they have to add up to 180 degrees. That is just a rule for cyclic quadrilaterals, so you have to know that. So we can then say ABD plus X is equal to 180 degrees, and therefore X is equal to 180 degrees. And the reason for this, so before we compute the value, the reason for ABD plus X equals to 180 degrees would be that we have opposite angles of cyclic quadrilateral are supplementary, right? Okay, now that we have that, now that we know that the opposite angles of a cyclic quadrilateral are supplementary, we can basically compute the value of X, which is what we're interested in the question. So given this diagram and asked to compute the value of X, and so we can say X is equal to 180 degrees subtract ABD, and the value of ABD is 60, and therefore our answer for X would be 120 degrees. So that is that for that question. We move on to the next example which I have. So I have quite a few examples just so you know how the principles actually work, or you know how to basically apply them. So I advise that you do as many examples as you can, but please don't do too many. By too many, I'm basically just saying that there are a lot of variations to this and you can't finish them in time, right? So basically just focus on knowing the principles, and once you know the principles and you practice a few questions, then you know how to apply those principles to any other question. So practice as much as you can, but don't waste too much time on this, right? If that makes sense to you. Basically, I'll say that again. So basically just know the principles, and if you really know the principles, you can know how to apply them. So after practicing and going back to the principles and going back to your examples, you'll have enough confidence to do just about any question, instead of spending all your time doing all the problems which you possibly can, right? So once you know your stuff, you basically can apply it. That is basically what I mean. So now I have this question here, given O as the center, and we are asked to find X, which is over here. And to start with, we can just find this other angle here, right? Let's call it O1. So O1 is equals to 360 subtract 124. And the reason for that would be angles around a point. So angles around a point add up to 360 degrees. If you remember from my previous video where I talked about circle geometry and straight lines, or from class, or from wherever, if you remember that, that would be cool. So then our O1 would therefore be equals to, so subtracting 124 from that 360 degrees that we have over there, you're basically gonna get a value of 236, right? And now that we have this 236 and we're told that O is the center, we can say that the value of X is equals to O1 divided by 2, and the reason for that would be angle at center. We know that the angle at the center here is equals to twice the angle at the circumference, right? And that is why we're saying that X is equals to the half of O1, and therefore the value of our X would be 236 divided by 2, and that should give you 118 degrees. Now that we have that, we are basically done with the question, and we can move on to another question. You can write it in full. Just say angle at center equals to twice angle at circumference, right? You can move on to the next question that we have. Okay, let's move on. This next question, we have O as the center, and we're given 110 degrees for that angle, the value of that angle there. And we're asked to find X, and X is situated over here. So once again, this is a cyclic quadrilateral. 4 vertices are touching the circumference, and therefore we can start thinking about the principles which apply to cyclic quadrilaterals. And so let's start. So here you have 110 degrees, and you have this angle over here. You can just call it P. So P is equals to half of 110, and the reason for that would be angle at, so the reason is the same as the one in the previous question. So angle at center is equals to twice the angle at the circumference, right? And therefore our P will be 55 degrees, right? We now calculated that our P is 55 degrees. We can just write it so we remember. Now that we have this P of 55 degrees, you can come down here and look at this point. It's actually called Q. I forgot to label it. Q, right? And we can call this Q1, and then the other one will be X as given in the question. So now we can actually calculate the value of Q1, because Q1, so Q1 plus P equals 180 degrees. So this P over here plus this Q1 are equal to 180 degrees. You have to provide a reason for that, and the reason would be opposite angles of, so opposite angles of cyclic quadrilateral. So the opposite angles of cyclic quadrilateral are supplementary, and that is the reason. So the opposite angles have to add up to 180. This and that have to add up to 180, and this and that have to add up to 180 respectively, right? So we know the value for P because we just calculated P not so long ago. We can just continue and say that Q1 is therefore equals to 180 degrees subtract P. And therefore your Q1 would be equals to 180 degrees subtract 55, which is basically equals to 125 degrees. right? So that is your value for Q1. And this Q1 is actually going to help us to find our X, which we're interested in. So X plus Q1 is equal to 180 degrees. The reason for that would be angles on straight line, because they occur on this straight line, which is given to us here. So they basically have to add up to 180 degrees. So this diagram is actually badly drawn. This line, if you look at this line here, it is supposed to be, I'm not sure how I can do that. Okay, let me do this. I'm going to take this. I'm going to take this out and draw this properly, just so you see what's actually happening here. So I didn't draw the diagram correctly, but I hope you're following so far. So if I draw a line like that, that is the line which you should have, so that these two are along the same straight line. So you have your X and you have something like that. So the straight line only consists of this X, which we have in our question, and our Q1. So Q1 and X equal 180 degrees, and the reason for that will be angles on straight line. Now that I fixed the diagram, this actually applies, or this is actually true. So Q1 plus X is equal to 180 degrees, because angles on a straight line are supplementary, right? And therefore we know the value. So we know the value of Q1, we just calculated it here, and we can then find the value of X, and X would be 180 degrees subtract Q1, and the value of that would be 180 degrees subtract Q1, and that would be X equals to 55. Now another interesting thing you would have noticed is that this 55 is the same 55 which you have at the top. Now if you knew that principle that talks about the exterior angle of a cyclic quadrilateral, then you'd basically just have applied that. But if this was your approach, if this is what you saw first, then you'd basically do this, right? And now we continue to, I think this is the last example. Okay, this is the second to last example. So I have quite a few for you guys. I hope you're happy. So then let's move on to this particular example, which is our next example. And in this example, we asked to find quite a few things, and you can actually just speed through these kind of questions if you know what you're doing. That's a good part of it. But the bad part is if you don't know anything, you basically can't even start. So once again, please familiarize yourself with the principles, the theorems, and everything. It will be really, really helpful to you. So in this diagram, we're given 50 at R. We're given 70 to be the value of RQP. So you can write that down. So RQP, which is this whole angle here, it's given to us as 70 degrees. And we're given POQ as 100 degrees, which is written like here. It's 100 degrees, and also given 50 at the top at R, which is quite evident, or it's visible. And we're also given 90 degrees at STP. It's equal to 90 degrees. Okay, so you can now start, and we're told that O is the center and O is over here. We're told that it's the center over there. And we can now start finding the values of these. And the first question is asking us to find POQ. So where is POQ? Let's first go to POQ. So POQ, is that it? POQ, okay. So this value is actually not part of the question. So I actually wrote the answer for you guys. So you can just write that down. So let's just proceed to write the answer for that, because I already wrote the answer for you guys. And the answer of P to this first question is 100. And the reason for that would be that angle at, so in the question, you were actually just given 50 and not the 100. You're just given the 50 at the top. I just mistakenly wrote the 100. So now we can just say POQ is equal to 100 degrees. And the reason for that would be angle at center. So the angle at the center, which is POQ, is equals to twice the angle at the circumference, which is 50 at the top. And that is why this POQ is equals to 100 degrees. So now move on to the next question, which is asking us for PSQ. So PSQ is over here. PSQ is over there. PSQ, right? So we know that this is 50. It's given to us in the question. And if you look at this arc, it subtends PSQ as well as PRQ. And therefore, we can say that PSQ is equal to 50 degrees because it's in the same segment as PRQ. So angles in same segment. So basically, this angle is equal to that angle. If you just revise your theorems, you'll see that that is the case, or that is true. And if we move on to something else, we can, okay, OPQ, let's look at OPQ. Where is OPQ? So OPQ is over here. Right? Now, once again, we weren't given that these two are actually equal. So this was not supposed to be in the question. These lines were not supposed to be in the question. But if you look, these two lines actually originate from O, which is the center. And any line that originates from O and goes to the circumference is a radius. And that line is also a radius as well, which means these two have the same value, or they have the same length. And therefore, that is equals to that. So this line is equals to this line. And now that we have this angle here as 100, we can actually calculate the two angles which form, or which are part of the triangle, because then we have an isosceles triangle which looks something like this. So we have POQ. Here we have 100 degrees and we have equal lines, and therefore that angle and that angle are equal because they form an isosceles triangle. And therefore we can find the value of that. So let's call it x and call it that x. So 2x plus 100 is equals to 180 degrees. So 2x is equals to 80, and therefore x is equals to 40 degrees. And the reason for all of this is angles of isosceles. That's not how you spell isosceles, or is it? Okay, isosceles. Let's write it in full. Isosceles triangle, right? Angles of isosceles triangle, and they're basically the base angles, and they should be equal. And therefore, we now have a value for our OPQ, right? So OPQ is therefore equals to 40 degrees. And the reason for that would be angles of isosceles triangle. Okay, so now move on to SPT. Where is SPT? SPT is over here. So SPT is over here. You correctly identify that that is 50 because of angles in the same segment from the previous question. That's PST, or what's it, PSQ? Yeah, that's PSQ. Doesn't really matter. There it is. We found that to be 50 degrees, and we know that this is 90 degrees. It was given to us in the question. And therefore, the final angle, which is SPT, we asked about SPT now. We can just say SPT is equal to 180 degrees, subtract 50 degrees plus 90 degrees. And the answer for that, or the reason for that, would be that third angle of triangle, or angles of triangle. So it is the last angle, and it has to form, the sum of all three have to form 180 degrees. So we subtract the other two from 180 degrees to actually find the value of SPT. And therefore our SPT will be equals to, this is 140, it should be equals to 40 degrees, right? The final question from this diagram is asking for TPQ. Where is, okay, TQP, that is. It's asking for TQP, which is the small angle over here. This small angle here. TQP. QP, that small angle there. So how can we actually find that? Excuse me. So if you look at this angle here, it's given to us as 70, and it is all the way, like it's all the way from that point to this point is 70 degrees, right? And if you look at this here, this angle here, which is SPT, which we just found in the previous question, it's 40. And this 40 is the same as the angle which we have here. Because of the angles in the same segment as R. So it subtends that angle there, also subtends this angle there. So according to the theorem, it says angles in same segment. So you can basically say that so this is to answer the question. You can basically say that SPT is equals to T. So where is it? TQR, and that is equals to 40 degrees. Right? Now that we know that we have 40 degrees over here, we know for sure that we have 40 degrees over here, then our task is now to find the remainder, which is basically TQP. So you know that this red part here is 40 degrees, and the reason for that is angles. So we have angles in same segment, and that is why part of this whole 70 degrees, so part of this whole 70 degrees is 40. So this part is 40 because of angles in same segments in the same segment as this one over here. So that and that in the same segment. So if we take out 40 from this 70, then we're left with our TQP, and that is what we want to find. And therefore, TQP is equal to 70, subtract that 40, which we found, and the value of this should be 30 degrees. All right. And that is all with regards to this particular question. I hope you could follow, even though I made quite a mess of the diagram. This is probably what you do as well in test situations. You'll have a messy diagram, but it is expected. So now come to the final question, which I have prepared for all these examples related to circle geometry. And let's get right into the question, right? So given this diagram over here, and from this diagram we are basically asked to find, so O is the center, DE is a tangent, and we're told that AOE and BFC are straight lines. That is what we're told over there. And we are asked to find the following. So asked to find A2, E1, C2, and A1. So okay, let's start. In terms of X, because this E2 is given to us as X, so we're asked to find those values in terms of X. So what can we say about that? So the first thing you would notice is that you have a tangent. So this is a tangent over here, and you have a chord over here, right? So you have a theorem that says this angle over here is equal to that angle over there. The reason for that, so this is the first question. The reason for that would be tan chord theorem. That is just a theorem which you can just quickly apply. Now moving on to the second one, so let's just write it up here so we can see the diagram as we work. You can write it somewhere here. So E1, where is E1? So E1 is basically the one which is right next to X. It's over there. So now we are told that O is the center, and we have a line that passes from the center down to the tangent. And we know from that, or we can say that OE is perpendicular to DE, because we have a line, or we have a radius from center or line from center perpendicular to the tangent. That is just a rule, or that is just a theorem. If you have a line, a radius, or a diameter which moves from the center to a tangent, it should be perpendicular to the tangent, which means that you basically have this whole angle. You basically have 90 degrees on both sides. So you have 90 degrees over there and 90 degrees over there, which means that the value of your E1 should be equals to 90 degrees subtract X, right? So that is your reason. So you can change this line to something like, in specify and say diameter. So diameter perpendicular to tan, something like that. You can specify perpendicular to tangent. And so that is your E1. You can move on to the third one, which is C2. Let's just keep the diagram in the frame. So we are now dealing with C2. So I can basically just erase this information because we know about it. And so we can work closer to the diagram. Now at the third question, and we asked to find C2, right? So let's look at C2. C2 is situated over here, situated there. So how can we actually find this value of C2? If you notice here, we have a line that moves from the center and it goes to a straight line, and it divides the straight line into two equal parts, which means there's a theorem that says this is therefore perpendicular. So OF perpendicular to CF, and the reason for that would be you have a line that splits. You have a line that splits. So you have a radius that splits. I'm not quite sure about the exact name of this theorem, but the theorem says that if you have a radius which goes to a line and it splits the line into two, then you basically have the radius perpendicular to that line. Also, if you have a radius perpendicular to a line, then you have two equal sides. So that is what the theorem says. It has two sides. There's the original theorem and there's the converse. So basically, what we've concluded now is that OF is perpendicular to BC, or FC, doesn't really matter. And you're going to give this reason as I'll give you this as homework. But there is a theorem. I'm just not sure of the exact wording. There's a theorem for that. So that is your homework. Now that we know that this is perpendicular, then all of these angles will basically be 90. So now we can look in the triangle FCE, right, where we have E1 and we have F3 and we have C2. So now that we know this is 90 degrees, now that we know that this is basically 90 degrees, subtract X, we previously found that was E1, which is from question 2. Now that we know these two, we can basically say that C2 is equal to 180 degrees, subtract 90 degrees, subtract 90. So basically subtract 90 degrees, subtract X. This is one angle. And this is E1. So basically, and the reason for that would be angles of triangle. And ultimately, you should get that C2 is equals to X. So you basically have your 90 degrees over here. You basically have your 90 subtract x here as your angle in terms of x, and you're asked to find this here. And that is what I basically did. And the answer you should get for C2 should be C2 is equals to x. I can just quickly erase that so that I create space for question 4, which is asking us for A1. So question 4, we have to find A1. So A1, this is question 4, we have to find A1. So where's A1? A1 is over here. What can we do to find the value of A1? There are quite a few ways you can actually find that value. And the first one, or the simple one, would be that if you look at this arc over here, it subtends that angle. It also subtends that angle over there. So basically, A1 is equals to C2 angles in same segment. And therefore, A1 is equals to x, because we previously found our C2 to be x. If you look at this from the theorems, if you look at this, you can see that this and that in the same segment, or is subtended by the same arc BC, right? And that is all that I had for this video. I basically covered a lot of things and a lot of theorems. But again, once you know your theorems, you can basically solve any question, and the more you practice, you basically know how to solve these faster. So practice, 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 but most of all, make sure that you know your principles. Once again, if you haven't subscribed, please subscribe to my channel. And if you like this video, give it a thumbs up. And I will see you guys in the next video.